what made you think of, hey, I can do this? Like, let me go gather up $200,000 from somewhere.
Arrogance.
Another question that I had was, in the explanation of what you just said about steel, have you ever tried what I'd call mutts? Like, I've been labeling them mutts, like where you're taking one layer may be iron, one layer may be nickel, one layer may be something else, or like half is this and then half is this, and does the order affect it? You know, I've always thought of those questions.
That's exactly what that is.
Wow.
Okay.
Wow.
This is what's interesting about that. So, nickel is more expensive than steel.
Yeah.
Right? And so in the early days of sound techniques, you had the transformer companies had choices. Some of them called it radio metal, some of them called it audio metal. So you had steel, audio metal, or nickel.
They literally named it radio metal.
Radio metal, yeah, one of those two, depending on the company.
Okay.
And so nobody really knew what it was. You know, it was kind of like, what is radio metal? They said, well, it sounds like nickel, but it's cheaper. I'll go with that. You know?
Gotcha.
So what it basically was, we couldn't figure this out. So we went through all these papers, and a friend of mine worked at Hewlett Packard in one of their analyzing departments. And they do they bombard things with electrons to find out how things work. And so we sent him, the guy said, hey, my friend is retiring, send him some laminations. So it was like, you know how it is. Okay. Yeah. I sent him like 27 different laminations from everybody, you know. And what we found was the early transformers were 40%, I think it was like 40% nickels, 60% steel. Okay. The later ones were like 30 and 50 with all these like pollutants like palladium and copper and iron and
a bunch of alloys.
Yeah, a bunch of alloys that it wasn't pure. They weren't pure alloys to begin with. So, and it in a mic transformer, you gotta remember it steps up. So it's gonna multiply those anomalies by a lot, so people are gonna hear them. So that was one of the reasons. So we figured that out, and he had an alloy actually made. And so, you know, getting alloys made nowadays are really hard. In the old days, anybody would do anything. Okay. But nowadays, you're talking about an alloy. So how much of this alloy do you want? Do you want an ingot, which is like, you know, quarter the size of this room?
I'm about to say, what is that? That's
where do I put it?
Never heard that.
Can you move that, please?
Yeah, I've never heard that in my life.
So what we found with the Sunset sound output transformer is that the nickel one, which is in like a lot of the Jensen mic pre's and stuff like that, they were just too clean on the low end. There wasn't a lot of character to them. Steel, a little bit heavier. Okay. So they went with a 50-50 alloy.
Gotcha.
And the 50-50 alloy worked fine. Well, again, nobody wants to make alloys. So we went, and David and I played around with it, and we found that alternating laminations, steel and nickel, it was like 50%. It was the same.
So in the basic same IE configuration, you're just overlapping one over the other.
Over the other, because they're like E's. They overlap like that. And so you accomplish the same thing. Yeah. So this is a 50% nickel steel transformer. And with my output transformer, you can see here, I actually have 4 nickel laminations in the middle, because I wanted to I wanted to calm it down a little bit, but not all the way. So this has a little more low end distortion than this does. But that kind of smooths it a little bit. Not a lot, just kind of brings it down a hair. But that's one of the things. So that's also a cinematic transformer. So that's the interesting thing about this transformer. So it's exactly what you thought is that's what you could do. And when I was doing the original Tone Lux transformer, I was playing around with laminations. I had the transformer company wind me bobbins, and then I would stuff them. Gotcha. I would test them and listen to them. Gotcha. And I found that this certain particular type of steel they had was actually pretty good. And that's what I went with, was the steel.
Do you have a particular, I mean, these are just random questions, but do you have a particular company or bobbin that you liked? Do you 3D print them now? Does the bobbin even matter?
Well, I thought it, like with the Tone Lux stuff, I had an inch space.
Okay.
And I needed to get as much around that transformer as I could. So I designed the bobbin, and I actually had it made to the point that the core area, you could literally see through it. It was so thin, because I wanted if I could get 3 more layers around that core, then that gave me 3 more layers and I didn't have to make it fatter. So I did that. But one of the things it's taught us is this metal alloy content is extremely important. So, you know, when you talk about like Pultec and about Steve Jackson, you know, we acquired Pultec in the first of the year,
which I'm extremely happy about.
Yeah, and it's good. And Steve is, you know, one of the smartest people I know. I mean, the guy is just like beyond, just way over there. He went through the process of analyzing the metal, analyzing the copper and the windings, analyzing the lacquer, went through all that kind of stuff to find out what it really was about. And what he found was interesting, because now you get all these people to make the clones.
Right.
And they sound like the ones they had, which are 50 years old.
Right. It doesn't sound like when it was brand new.
Right. Yeah. So they make all these things. So in 50 years, those things are going to probably sound like ass.
Right.
You know, and these are going to be consistent. So what Steve wanted to do is he wanted to find out how they're really going to make. And I told him, I said, okay, you're going to have one problem. I said, you're going to do this, and they're not going to sound like the old ones, and it's going to be balls to the wall to you. So you got to get in front of this and say, no. These are what they sounded like when they were new. And then it becomes a feature. So that's what he did. And that's one of the things. But they sound just like they did. And he has gone through more shit getting those transformers to sound right. And that's 99% of it. Right. The tubes, they have to do with it. You know, obviously carbon resistors versus metal filament. You know, carbon, they found that carbon actually has a very high second harmonic content.
Okay.
So if you replace all your resistors in a tube amp with carbon resistors, it's going to sound different. It's going to sound warmer just because of the fact that it's additive.
Right.
You know.
Also, this board, when it was made, it was running on 24 volts, right?
Yeah, the original ones were plus or minus 24.
So now, I guess this is just for me as someone who, you know, is into 500 series gear. Is there a difference in design when you're restricted to this plus or minus 16 volts?
Well, it's not really a restriction, because you got to remember that dB is logarithmic.
Gotcha.
So, you know, from here to here, it's twice as much. Here to here is twice as much. Here to here is twice as much. So what happens when you get a 2-to-1 transformer and you have plus or minus 16 volts, you will have like plus 29.8 dBu coming out, okay? Which is more than any piece of equipment on the face of the earth can handle.
Right.
All right. And you're typically running, you know, in the 20s. You know, you still got 8 dB way above where your peaks are, because of just the way things are. If you go to plus or minus 24 volt rails, you basically increase that by like something like 1.3 dB.
Gotcha.
And if that makes that much of a difference, then have at it. Yeah, you know.
Right.
But it really does not make a difference. Now I think with the Sunset version of theirs, their output transformers were wired 1-to-1, so they still had that clicker.
Gotcha. But being as you got the bump.
Yeah, we got the bump from the transformer. Now, the one thing about the transformer, you talk about 600 ohm loads versus open loading. In the old days, everything was 600 ohms because the tube outputs, you know, those transformers were this big, and they needed a load to make the transformer stable. So they would always have a resistor on the little screw terminals. And on output of those things, they sound better if you put a 600 ohm resistor on them.
Okay.
They do get a little squirrely. The original 550As, they ran into a 1K or a 600 ohm fader. So So
the fader was the resistance.
The fader was the resistance.
Wow, I never knew. Okay.
Yeah.
Okay.
Now, and it's like everything leads to a mouse rabbit.
Yeah.
Everything's another rabbit down the line. So when you have a fader, you notice how the fader has the top, the wiper, and then has the ground, and then has another ground, and that's called a hop off. Okay. And what they would do is, because a 600 ohm fader coming off of the audio, it actually, if you're really driving it, that fader will be warm.
You know what? It's like, you know these things, but you don't put them together. It's like, yeah, that is what you're doing.
Yeah.
When you're turning down a fader, or really turning it up, because it really works in reverse. But then, it is a resistor after.
Yeah.
I never thought of.
And if you're driving current through that at 600 ohms, then that element is actually warming up a little bit.
Wow.
when you pull that fader down all the way, it's not going to turn off all the way.
I'm not saying wow, like we reinvented the wheel. It's like the simplest concept that I never thought of.
I know.
It's like, oh,
And it's,
1 + 1 does equal 2.
It does, and the thing is, and the wow part of it is like, oh, that's why, and that's what I look at it. It's like that's why when I turn faders down, they don't always cut off.
Right.
And that's because the current going through that element was such that when you pull it down all the way, there was still enough current to pull that up that it wouldn't turn off. So what they would do is they would take the substrate and they'd cut a 45-degree angle on it. And as the wiper, because the wiper had 2 sets of terminals, as the wiper crossed over it, it would transition onto the ground, which was disconnected. And then when it hit there, it was off that coil and it was on the ground. And that's called a hop off. And that's why a lot of those faders have 2 grounds. It's one's a hop off and one's most of the time now.
Thought about it like that.
Yeah, and with a 10K fader, you don't need a hop off.
Right.
You know, but when you get down to 1K or 600 ohms, yeah. And so the 550A was also designed. There's on the back of it, there's that gain pin. Okay, in the days of making simple mixers, they didn't have all the insert points because you had a compressor, you have the mic pre, you go to a compressor, you go into the console. I mean, that was all you had, you know. So they didn't have that insert point post fader. So the fader a lot of times was the driving amplifier for the EQ was the driving amplifier for the fader. So you didn't need another amplifier. So you could build a console with just the EQ. So you'd have the mic pre, your compressor insert point, then you have the EQ, then you have the fader and the panner and the level. And the EQ, if you grounded that pin, that fader, the EQ would actually go up to 12 dB a gain. And that's why on the fader, if you look at the fader, grab this here. If you look at this fader, this 0, and you see you got 12 up here.
Right.
Okay, so you're running the fader, you're attenuating at 12 dB. Well, now you're 12 dB down. So if I drive that fader with plus 12, then this is unity, and that's actually gain, and that's cut. So that's why they would do it. So it was the pre-fader, booster amp.
Yeah.
And then the output of the fader would drive the pan pot. Now the reason the faders were 600 ohms or 1K was because then the pan pot could be 10K.
Got you.
And you wouldn't have the pan pot wouldn't load the fader.
Do you have and this is again just random because this is amazing. Now we get to the pan pot. Do you have a preference on what the log of those are?
Yes.
Okay.
3 dB down.
Gotcha.
Because that is because I come from the age of mono. Okay, so you pan it to the right, it's 3 dB down. You pan it to the left, it's 3 dB down. You put it there, or it's full up and 3 dB down in the middle. You sum those together and it equals 1.
Gotcha.
And so you always want, when you're doing your mono compatibility, you want to make sure that it sounds the same. You don't like lose a vocal or something because.
For my students and just audience. Understanding that once I got into building things and I did this thing where I messed up a piece of gear so bad because I was just like, oh, I know what I'm doing. Like maybe the third thing you're putting together. And I just started throwing stuff in there. I'm like, oh, these all go here. And I had put 50Ks where 10Ks were supposed to go. And then I did not. And that was my thing of like, oh, these pots have like different logs on them. And then so just for the audience, like this knob could be completely different in terms of like if it's 10K, 50K, whatever. Yeah, okay.
And that's the thing. And the old rule, there's a thing called, it's a bridging rule. And it comes from the broadcast days. And like a bridging transformer, the reason they called it a bridging transformer, and a mic transformer is basically a bridging transformer,
right?
Is that your source impedance, whatever that is, the transformer has to be 10 times.
10 times as much.
Right, and that guarantees that you're loading less than a dB.
That's another point that I think students and people in the world have heard this thing. My students will come to me and they'll say impedance matching.
Yes.
And they assume it's supposed to be the same number, but just because the word matching, and I'm like, have to get this concept of, if you're here, you're supposed to be 10 times, at least 10 times above this.
A mic transformer is not a matching impedance to
right.
It's the correct transformer, but it's not a matching transformer. A matching transformer is 600 to 600.
Right.
Which means that whatever you loaded on that side gets reflected on this side.
Right.
So a mic transformer, it's 1500 and the mic is 150.
Yes.
And a pad is 150 on the mic, or 1500 on the mic and 150 on the transformer. And that's how you get the pad. And a correct pad that's only got 3 resistors can only be 20 dB.
Gotcha. Okay.
And that's one of the things. And what you do, of course, when you're coupling the two transformers in the microphone and the transformer in the mic pre together is they tend to wiggle around a little bit, and you get a tone. When you put a pad in there, you lose that tone.
What's your theory or sort of idea on buffers going in or
I mean, a buffer separates you from the transformer, so you're going to have that same thing. The microphone. Now we have a mic pre that we call the ref pre, that is this right here is designed specifically without a transformer, so it loads the microphone. But this is designed for things like ribbon mics and stuff like that. And so there's actually a ribbon thing that adds 10 more dB gain. But it's designed that if you like the sound of your mic and you don't want to run it through something like this, then this mic pre gives you that clean sound. And if you're doing microphone sampling, like you're doing like a Slate, VMS microphone, going to a pre like this guarantees that you're taking that microphone and putting it directly into your circuitry without coloring it, because now you're coloring, you're altering it, so now its reference is not the same.
Right.
So this gives you that. This is what this is designed for. And for ribbons, it's nice because ribbons have a kind of a tone of their own. And this kind of can make it heavy.
So much gain.
Yeah, and they also this transformer is 150 ohms. Most ribbons are 200.
Yes.
So they don't match. This when you switch this, it changes the load impedance. So it's correct. But that's an interesting thing, because it all has to do with things. And now impedance is an interesting thing. So this is one of the things that I constantly bitch at this, and my daughter did a thing in school that got the teacher graded her incorrectly, and I went in and argued with her about it. And so what it basically was is they had the old thing where you have the shadow and the telephone and the flagpole, and you want to figure the hypotenuse, that kind of stuff, and you're going like, when have you ever in your life wondered what the hypotenuse of a flagpole with a shadow is? Ever?
No.
Yeah. And that's the example they teach you. So most kids glaze over. Well, that formula is the basis of resistance and reactance, because reactance is pure magnetic, resistance is pure load, and those two together give you the impedance.
Gotcha.
It's the same with fluids, same with lift and drag on an airplane, same with air pressure, same with everything. It's that same formula. But that's the thing, is that it's that calculation, but no one ever does that because no one cares.
Right.
But when you're dealing with electronics, that's impedance. And there's all kinds of different formulas that use that same Pythagorean theorem. I mean, that's sine, cosine, tangent. That's what that is. Right. It's the same thing,
That's
so,
I guess stay there for a second, right? Because there's a thing of people going to school or like say people that want to become interested in electronics. And one of the first things that I did was like look up just a basic EE course at a university, not even just concentrating on audio, but just electronical engineering, period. And those are the parts that I think people don't see of like how much it's not complicated math, but it is this math. Like you need to know these things in order to design gear. Then it makes it super,
or to at least understand why it's doing what it does.
Yes.
Why does the microphone sound different when I switch in the pad? Well, you're going from a basically reactance based. The two transformers doing this because they're bouncing around and they're reflecting on each other. They're like that because they're not tied down to anything.
Right.
You're putting resistor in there, now they're like, good students. So that's to understand that. Why does it sound different? Well, this is the reason, because you're removing the reactance factor in that impedance link, and you're basically dealing with pure resistance.
Right.
And it's like, oh, okay, because now that transformer is going to become very stable. So its impedance is going to be consistent, whereas that they're acting together, different frequencies is going to be different things, and it's going to sound totally different.
How much of the stable, unstable, how much of taking math out of it, how wrong should we be? When does wrong become right? When it becomes your particular taste? Like I could design something that's technically on paper perfect, and then you may have something that has a little bit of wiggle room or tolerance is a little bit, and it sounds better.
Yeah, you see, this is the thing. It all has to do with the sound, because like my EQ, it's plus or minus 15, but one of the bands, when you get up in the high frequencies, it only goes up to 14. If I made that 15, then it changed the way that the whole circuit worked. It wanted to roll off a little bit, so I let it.
Gotcha.
And if you get too wrapped up in the technological part of it, the singer's going to sit there and go like, anytime.
You're right. Right.
You know, and that's why a lot of times you put two, if you don't know the singer, you put two mics up and let him sing, and then you have them both. And then you take those two mics direct to tape, take those two mics, two compressors to tape, two other compressors to tape. I mean, that's what they would do with Frank Sinatra. He would come in and they would take his mic, U47, and they would put it through a direct, a compressor, a different compressor, and a different compressor, because he would go in once.
Gotcha.
And that's the guy you don't want to say, hey,
you got to do it again.
Come back tomorrow.
Yeah. Gotcha.
I mean,
that part of it is I'm asking from the standpoint of like, yes, you can like culinary school, right? You can have the recipe that says this tablespoon of this, and then eventually when you're cooking, you're going to get to the point of like, let me throw a pinch more salt in there. It's not wrong. Salt's not better than pepper. It's just like which one do you?
And then my great grandmother has a recipe for oatmeal cookies that is they're just classic. These guys have all had them. We had them at the factory here. They're just like, oh my God, you know. And I have the original recipe that she wrote, and at the very bottom of it, it says more or less.
Got it. Yeah,
so,
do you think that? And that's a great question. Do you think that those things, like, do you think we've fallen in love with 990s and 2520s and all these 1731s and all these things just because that's what you guys were using, and you've made such classic? Like, would they matter as much if the Beatles didn't use them, if Frank Sinatra didn't use them, if so, like, would they matter as much?
How many studios get phone calls like, well, do you guys have a U47? It's like, no. Oh, click, because Jay-Z used
right.
Okay, well, that microphone has a lot of sizzle that it adds that's not like technically registered on its graph. When you have, like, I'm talking to you right now, I have the ambience of the room and your voice sounds a certain way. When we listen to it with these two mics, it's going to sound different. Now, your brain has like candy receptors.
Okay.
So if I take your voice and I put it through a U47 and I go in the control room, I go, wow, that sounds just like him singing. You know full well it doesn't. But your brain has had one piece of candy replaced with another, so it says that is the same.
Gotcha.
What it does is it does the same thing to you.
Okay.
You see, so your brain is happy.
Okay.
If your brain starts thinking about shit, then that's when you get fatigue, and then you're not listening to the music. You're not listening to the song, you're listening to the sound, and your brain is going like, there's that cowbell annoys the hell out of me, and it's just because maybe it was a Lindrum cowbell, and you know that it's fake.
I love the way you said it does something. If it does the same thing to you, you're not.
And your brain will just say, yeah, that's fine, and it's not. You know it isn't, but it's like you have a jar of water or a glass of water, and it holds the same amount. And you drink one or the other, and they both do the same thing. And you say, yeah, that was a good glass of water, even though it was a jar.
Right.
Right. And the other thing that's funny about that, too, is if you go into a bar, they have the round glasses and they have the tall glasses. Yeah. They all hold the same amount.
Same amount. Crazy.
I want mine tall. Whatever. Okay, here you go. Twice as much.
It's just a question I have, because I'm like, I have people that are, they're like, I'm like, I just know NS10s. I'm telling you, they're not the greatest speaker in the world, but they've served me for 30 years. So, I use them, or we fall in love with certain things, and I think it's because of the lure of what those things are. And sometimes
there's that.
Yeah.
There's that. But an NS10 does something very specifically. What you do is, if you make it sound good on an NS10, it tends to sound better on other speakers because of what it's lacking.
Yes.
And then you get the guys that make new crossovers for them and stuff like that, and it's like, no, you don't understand. I want the wrong.
Right.
Yeah,
That's what I mean. I guess that's my overall point.
Yeah.
I want the wrong in certain places, even though we are technically going for excellence and the best thing that we can do with it.
The truth side of it is, if he knows that you're using this, then he's going to go inside. He's going to go, yeah. And so he's going to go out there, and he's already got a smile on his face. And then he sees the U47, and it's the same one he used in the other studio because you rented it.
Right.
Because they all sound different.
Right.
He goes in there and sees that scratch on it. He goes, "Is this the same mic?" "Oh yeah, we borrowed it for you." And it's like, wow, so not only did you make him feel like you're taking care of him, he's got the same mic, he's got the same preamp. He goes like, this is going to be good. Right there, he made his decision. And that session is going to be better.
Yeah, to do his best performance because you set him up for success.
And that is where the equipment, it has nothing to do with the specs or the sound or anything. It has to do with confidence. If you feel that you can get to this setting quicker on this mic pre, that's going to be your mic pre of choice. Now, it's going to sound really good. And when he comes through, it's going to sound warmer. And if his voice sounds warmer, the song is really, really good. Let's say we give the song a score of 96. One more point because this sounds really, really good. And one more point because that EQ sounds really good. Now you're getting into the 97, 98 range and you're nailing it. And that's why you get the right stuff. And it could be like an MCI. Maybe the guy adjusted it a certain way and got the sound. And the band goes, man, that's the shit.
Yeah.
I mean, it's like an SSL EQ. An SSL EQ, those guys would, a lot of times they would adjust it to get a pop out of the snare. But it was more, is it more like phase aligning the different bands so it popped? Or is it more of the sound?
Okay.
And the guys that I know that did that say, when you get it to pop, that's the sound you want. And that's the SSL snare sound.
Right.
Doesn't sound like the best sound in the world. You listen to the snare and it's kind of, you listen to just the sound of it and you kind of go like, I could have probably added a little more of this or that. But if you do that, then all of a sudden it starts to get mushy. And you go, wow, okay, so that's the snare sound because it pops.
Gotcha.
And that's the thing, that's the whole part of the tone of shit. And that's what all these things contribute to.
Right.
But it really has to do with confidence, Now there's one interesting thing that I've done. This mic pre is nice because this is the 2-to-1 and there's 2 op amps. I wanted to make a single op amp one.
Gotcha.
I had a custom transformer made that has a little less of ratio in it, so it doesn't put out as much. But every mic preamp that's out there, the APIs, all these different mic pre's, the circuit is designed in such a way where you have feedback resistor and you have the gain resistor on the op amp. So if that's 20K and that resistor all the way down is 20K, that op amp is running at 6 dB a gain. It's 20 to 20, so that's a 6 dB a gain. So that amplifier at its lowest setting is 6 dB a gain. Now you got a transformer that's got a 10 or a 15 to 1 ratio. Now you've got enough signal that if you hit the snare and you turn the gain down all the way, you're still going to clip it because it's up too high. There's nothing you can do but put the pad in, and that's where you go, oh no,
I've grown the sound.
So what I did with this is I thought, okay, I know this does have a pad because sometimes people want the sound of the pad because it does tend to tighten things up. But I set it up so with this gain switch, all of our mic pre's have a gain. The gain, everything is in the same positions. All of our knobs,
Got it.
selectable gain,
Got it.
trim, and output level. And the same with the ref pre. It's the same layout. But the way this is set up is the first position, the output of the transformer is actually padded down.
Okay.
Not the input.
Got it.
So it's padded down 10 dB.
Okay.
Then the op amp is running close to unity.
Okay.
So it's actually 3 or 4 dB lower than most mic pre's are. So you're already now 14 dB lower, plus this transformer has a few dB less of gain. So in the 0 mode, you can put a snare mic, a 57 right under a snare and hit it as hard as you want, and this will not clip. So you got drums, and that's the big thing is having drums and have that interaction, because you're hitting it with a peak and that transformer is going to bounce. And if you tighten that up, it's going to change the sound of it.
Yes.
Same with the vocalist. If he's really wailing on it in a tube mic, you're putting out a lot of voltage, and you got to use the pad. The transformer has a 10 dB pad on it, or the mic input goes into the transformer. The secondary of the transformer has a 10 dB pad, and then the op amp is running at unity.
Right.
So this actually has probably 14 to 16 dB less gain going in. So the mic going in can be at plus 18 before this clips. So that's one of the things I wanted to be able to capture a kick drum and a snare drum without having to use a pad. So then the next position, this pad on the mic input, the output of the transformer goes away, but the amp is still running at unity. Okay. So it's still lower. Then the next position is now this is running at 10 dB a gain. And then it's 20 and 30, 40 and 50. Okay. So I did this on this thing, and I swear to God, it's everybody that has them now is just like flipping out. And we did this. This was the real reason we did this was because people were complaining that we didn't have, microphone preamps in the console. So I came up with what we call the W8.
Wow.
And the W8 is 30 pounds of shit in a 5-pound box. I mean.
So this has that same design. This is wow.
Yeah.
Wow.
You don't want to drop it because it will hurt and it will break. And that just that slides off. And so this slides into the console like this. Okay, and it's got 8 inputs. Now it doesn't have the trim. It doesn't have the output gain control.
So this slides into the console.
This is the console. It will also have the option of an A to D converter with a Dante output. So yeah, and because the way we designed this thing, this front section pops off. Okay, so all your gain and your level stuff is all in this. So I can put on a different one, and I can have motorized pots or whatever. So we've got a whole bunch of stuff we're doing for the future for this thing. But see, this is the same thing. You got single preamp, transformer output like this, and then on the bottom you have all the relays. Now again, no pots, no switches. It's all done with switches. The rotary switch changes the gain right here, polarity, pad, phantom power. Everything is done with a switch remote controlling a relay. And then the pots, of course, are double pots, so they're redundant. And that's it's what it is. It's just like you don't want to be the guy that stopped the session,
right? Because
of that thing I told you about earlier.
Or somebody sending pieces back.
Yeah, it's like, and now, we get these back. We put one in Chris Fogel's studio in Glendale, and he was just starting the Star Wars new movie, doing the soundtrack on it. And so we had a couple of these go bad, and so he made his list, and we went down, we swapped them out. So you swap 8 out at a time, boom. He gets done with this session, and he said that the director told him that he's just never heard an orchestra sound so good in his life. And then the guy that was making all the notes and stuff handed him a clipboard that said no notes, because it just sounded so good. It wasn't anything to pick about. So that's one of the things that that I try to get to that point, because I don't want to be that guy. So we've got the Tootie mic pre, we've got this mic pre, we've got the ref pre.
Right, we've looked at this one.
And then we have the EQ. Now this EQ is actually very cool because it has it's parametric, but there's no Q control.
Okay.
Now like with a 550A or an old Neve or a Pultec like that, it's wider and then it gets narrower. And that's that. It's funny, but that's the reason you can never get yourself in trouble with that EQ, and that's one of the reasons you like it, is because you're never doing something that's like too narrow, boosting or cutting or whatever. So I did
both with the A and B.
Yeah. Okay. Yeah, the 550, 550A, 550B, the Pultecs, the Neves, they all had a proportional Q characteristic to it, and the reason they did that was because if you just basically go, let's say it's an inductor capacitor equalizer, which not very many are, but that's, let's just use that as an example. So that resistance, the resistance that's loaded on that is going to change. It's going to control where that center frequency is, because this is going to do 6 dB going up, this is going to do 6 dB going down, so you're going to have this bell. Right. Okay, but this is going to have a load on it. Now, if you change that load, the frequency point is going to change. But you can't do that. If you're going to change the boost and cut and it's going to change this load, you can't have the frequency moving around. That's like a Fender guitar amp. The tone controls on that was changed all over the place. So what they did was,
you got to put something on the bottom.
You got to put something on the bottom.
And
when you do that on the bottom, you degrade the filter, so the filter becomes wider. Okay. So with the 550A, the higher impedance is on the bottom, the lower impedance is on the top, so it's real wide. And as this right here and this go like this, the Q, which is the quality of the filter improves, and it makes it narrower. Right. Okay, so that's why it changes in Q like that. Now, a fixed Q, like a graphic EQ that uses a gyrator, you can do that. You can make those proportional, but they're pretty much fixed, so they tend to go like this. So what I wanted to do is I wanted to make a parametric. And the problem with a parametric is that no one's ever taught how to use it. Okay. If you use the proportional Q rule on a parametric, you can make it sound as good as you want. You just got to make sure you always remember boost little, Q very wide.
Got you. Okay.
So you want to go.
That's actually the opposite of the thought process of
exactly.
Like, if I take and I put this particular parametric, right, and if I take my GML, whatever it is, and I'm always like, this is the surgical EQ.
Yeah.
And I'm just like, I'm very fine, and I'm like, that's what I'm taught. Is like, this is the one that you go in and do surgery with.
Right, and that the nice thing about the GML is it doesn't have much color to it.
Right.
So you can put it on your mix bus, and you can make the changes you want without changing the color,
Gotcha.
which is important because you got it where you just spent the last 2 days mixing the song,
but
it's like, oh man, I wish it was just a little brighter. And you put a Pultec in there, it's going to make it heavy.
When you open it up, there's no electrolytics in there whatsoever.
No, there's not. There's a few, but it's basically all discrete amplifiers, but they're very precise, the circuitry. And that's when I did the Tonelux EQ, I used that same filter type circuit. When I did this one, I used a different one.
But I don't want to take us off. So you were saying,
so what I do,
talk parametrics, and it's to boost a little and then use the wide.
Use it wide, because if you do that, if you use that rule of inverse, the inverse boost and Q, then you can simulate a 558. So if you boost it a little bit, you make it wide. This right here, because it goes up to 12 D or it goes up to 15, it will actually go up to a third octave instead of an octave. So you can get a real tight, you can notch something. So what I do, if I have a drum that's ringing, I'll turn it up all the way and sweep this and find the ring, and bing, 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 bing. But now, not with this control, I'm doing it with the high and the low mid control. So I turn it up all the way, I sweep until I find that ring, and then I want to cut it just a little bit. Well, now I got a problem because it's real wide. So what I do is I press this button, and this locks it into a third octave mode. So no matter where I set it, it's always a third octave. So that now, when I notch this out, I can take a 1 or 2 dB and just get rid of that ring a little bit, because you want some of it there, but when it becomes too much, especially if the drummer's not smart enough to tune it to the track, if it's like a little flat, it's going to sound weird. So these two mid bands have that fixed cube mode.
Okay.
The other thing that I did with this EQ is I didn't want to have shelving, because shelving just basically goes up and it goes up forever. And that means your low frequencies go down to where the thing cuts off, and your high frequencies go way out to way beyond what an A to D converter can handle.
Gotcha.
So I did a wide button. So it just sets it at like 3 octaves wide.
Okay.
So no matter where it is, it's always 3 octaves. But because it's still proportional, it tends to go up like this instead of going like this.
Right.
And that just makes it a little smoother. So if you headed it, you have it set at 20K and you turn this up just a little bit, it goes way out there, but it still rolls off, and it's not going to make your A to D go splat. So that's one of the things. I wanted to make an equalizer that sounded good, that you could get sounds on quickly, but wouldn't get you in trouble.
Gotcha.
And that's basically what the Wolff Freak does.
Very nice.
And it has this is the older version. The new version we have has a
different
jumper.
Okay.
So when you hit the in-out button right now, this bypasses the EQ completely. And we have a jumper now where you can select it, that if you like the sound of the EQ out, it keeps the transformer and the amplifier in the circuit.
Okay, great.
Now this is interesting. I took 2 really good dual op amps. So there's 4 op amps.
Gotcha.
And out of the output of each one, I have a 20 ohm resistor, and I hook them all together.
Okay.
And then I hook all the inputs together. So they're all driving like they're in parallel.
Gotcha.
But they're all summing together and creating a 5 ohm load, which is enough to drive this transformer. But it's not enough to overload the individual amplifiers. I like the OPA 2134s.
Okay.
I just like the way they sound. It's not the quietest one, it's not the fastest one, but it has a nice warm sound.
Okay.
But I'll let you in on a little secret. I've been working with the guys at that corporation, because they make the balanced in, because I use the balanced in amplifiers here. I don't use the balanced out ones because I do it a different way.
Okay.
But I've been saying to those guys, your 1256 sounds so good, you should make an op amp out of it. So when at the last NAMM, the horror movies where the 3 triplets come up to you and they go, "Want to play outside?"
Right.
And they all say in unison.
Right.
Well, Les and the other 2 engineers from that corporation came up to me and said, "Here's some prototypes of the new op amp." So you know what? We'll go through this stuff because you'll love this. This is a real interesting thing. So this right here, I wanted to have something that an artist could use in the control room when they're collaborating. Like if you and I are writing a song together and we have headphones on, we have to take the headphones off to talk.
Right.
And it's annoying. So what I did is I put a microphone on this, and I put a gain control that feeds this microphone into these headphones.
Gotcha.
It also has a foot switch. So we can just sit there and talk. And it's just like we don't have headphones on. Yet we have headphones on. And this has 4 individual amplifiers. Now there's 3 of the top mastering engineers right now in the country that use these for their mastering.
Okay.
I actually modified one. And the guys at Odyssey, I just made them 4 custom ones that had the knobs cut off with just slots.
Okay.
Because they said people would listen to the headphones, and when they'd leave, they'd do that. just to be dicks. So they made them black. We put their logo on them, and they have 4 trim pots.
Gotcha.
And so they can plug their phones into it, adjust them so they all have the same volume, and then then they can mess with them. So they got 4 of these. So this has become quite a standard.
Okay.
And if you have a little interface, you plug the interface into this, and then your headphones into this, it's going to sound 10 times better. Because those Class D amplifiers, it's scientifically, but there's just something about them that don't have any life.
Gotcha.
And it's a,
What is while we're on that subject, what is your favorite? Do you have a preference of A/B, D, like in just terms of types of amplification?
Well,
it's huge arguments over Class A, Class A.
Well, yeah, and it's because these guys don't really know even how they work. Because in Class A, you can do 2 things. You can have a single-ended Class A or a differential Class A.
Right.
Differential Class A, the output is 0 because you got plus and minus voltages, so you don't need an output cap.
Gotcha.
If you're running on a single output, you have to go into a cap because you've got half your voltage sitting there. Now, one of the reasons why a Class A and Class A amplifier sounds so good is the real small stuff, because you're right at that transition point of going from this transistor to this transistor. So you're right at that transition point. And so a Class B amplifier, a Class A amplifier is 1 transistor, and it goes the whole rail. The downside is that if you want it to go plus and minus, it has to sit in the middle. So it's drawing half of its current all the time. So it never draws any more or less because the average is always half. Okay, so they get very hot. Now the reason they sound good, of course, is because there's no crossover point where they're going from one transistor to the next. A Class B amplifier is basically this transistor and this transistor, and they're biased. They're not biased, so there's a dead spot because the transistor takes, half a volt to 7/10 of a volt before it conducts. So conducting here, it's a dead spot. Conducting here, it's a dead spot. So there's this gap in the middle, which is the same thing.
It becomes the audible click.
Yeah, it's like no high end, because the high end is usually in that little gap.
Gotcha.
And that's the same with tape bias. Tape bias wants to go from south to north, like that. There's a hysteresis point that it jumps. It doesn't transition from north to south.
In some straight logarithm.
Right.
Yeah.
So that's why if you have high frequencies, which are less in that area, you're not going to hear them.
Okay.
So when they do bias, what they're doing is they're modulating the audio. So the audio like this, they modulate the audio so it overlaps. Minimum distortion, the minimum tape noise, there's a point where they're optimized. But when you run them a little harder, they might be cleaner, but they might have a little more noise, but they're going to sound cleaner. So that's why you over bias the tape sometimes.
Gotcha.
That's the same thing with amplifiers. So you're doing this thing with the amplifier. So a Class B amplifier, a Class AB amplifier overlaps just a hair. So there's the distortion goes down pretty quick, but there's still some distortion there. So if you have something, bass signal, it's the ratio of that little distortion to that whole signal is 100, 100 to 1. So you're not going to hear it. But high frequencies are real small, so that could be 50% of that high frequency thing is going to be distorting. So it shows up.
Gotcha.
The more you bias that into a Class A thing, if you bias it like this, they're Class A, but if you bias it just a little more, just to give it that window with the smaller stuff sounds better, it helps. And that's what I did with the ToneLux amplifier.
Okay.
That is actually, it's not Class A and it's not Class AB. I call it Class AAB, where instead of being here, it's like this.
Gotcha.
It's a little warmer. So Class A is going to be clearer, but then again, you run the Class A into a transformer, and the transformer adds its color. Now, there's another interesting thing about transformers, that transformers reflect a lot of magnetic characteristics on each other because the core is going up and down. So those reflections go back onto the amplifier driving it.
Okay.
Now, if the amplifier driving it has gain in it, then that gets put through that gain because it's on the output and gets fed back, but it gets fed back out of phase, comes back through the amplifier. So you get this repetitive, it's almost like an echo, but it's really fast, feeding back into the transformer. That has a lot to do with why it's second harmonic or third harmonic.
Gotcha.
Class AB typically has a high content of second harmonic distortion. Class A has more third harmonic distortion, and it's real interesting. So the ToneLux stuff had more third than second. The API stuff has more second than third.
Gotcha.
But the other thing is when you have this effect that this affects this, it changes with gain. So you have to make sure that your gain control is exactly where it was yesterday. You're not going to have that same harmonic distortion. Now with the Tonelux stuff, what I did is I used a power amp to drive the transformer, and the gain amplifier was before it. So you had none of this interaction. So the distortion was always consistent. So the louder you made it, the less distortion there was.
Gotcha. In the analyzation, when I'm looking and we say second and third, it's very easy for people to understand that. There's also never a case where there's just one frequency. There's all these things that are in between that second or that third on both sides. How much do those, when we're looking at our scopes and there's these little pokes, they may not be as big as the second or the third, and definitely not as big as the, whatever the starting point was.
Yeah, because it goes.
Yeah, but there's always all this stuff in between. That stuff, that no matter how small it is, how important is that?
You have to look across to where the level is.
Okay.
And a lot of that stuff, you'll have your fundamental.
Yeah.
Then you have your first harmonic, which might be 40 dB down or 30 dB down, and you're talking about in the 0.5 to 0.2%. You'll hear that.
Mm-hmm.
Then the next one, the fourth harmonic, which is the harmonic of the second harmonic. It's its second harmonic.
Right.
That might be down at minus 60. You're probably not going to hear that. Then its second harmonic is going to be minus 80 and it's pretty much gone.
Gotcha.
Now, same with third harmonic. Although third harmonic is not necessarily nice sounding in the higher frequencies because it sounds kind of harsh because it's kind of like not related to the scale as much as second. So you've got the possibility that if your low frequency distortion is going up too high, if it gets into the 200 to 300 range, it's going to sound a little off.
Okay.
But pretty much most output transformers, the second harmonic distortion starts at like 100 and starts to go up, and by 20 or 30 it's up pretty high. So your brain just hears it as being fatter.
Gotcha.
Third harmonic, it hears it as being fatter. And that was the trick I was telling you that Terry Lewis used, is he would put the kick drum through second and third harmonic outputs so that they both had that tree trunk. But it wouldn't affect you then.
Gotcha. Okay.
So that's a big thing, and that that understand that low frequency distortion is important because it adds to the thickness of your bass. So the next one is the Memore, and this is a headphone amplifier that you have a volume control, you have a balance control, left and right panner, and then you have the TQ, which is our tilt EQ.
Okay.
And the reason I did a TQ instead of bass and treble is because most people would just turn them both up all the way because it's going to sound better. They're going to go deaf quicker. That makes it brighter and thinner.
This is almost like a tone box.
Yeah, that's it. It's the same thing. It's the same circuit. Cool thing is this still has the mic for the bleed into the headphones, but this goes through. This has a compressor that at minus 15 it goes into a 2-to-1 compressor, so it makes it a little fatter.
Okay.
All right. And if you press this button, it comes out of this output and goes into the control room. So I can talk to the control room, but it doesn't talk to everybody. So
nice.
I can talk shit about the drummer.
Nice.
Control room. This Hear Me button right here, when you switch that on, this feeds the headphones. And this is nice, so you can set this next to a drum kit, and you don't have to send him reverb or a slap or anything like that, because he can turn up the room sound right here. And it's his drums right next to him. It sounds like the room. He can add as much as he wants.
Where does this come out?
This comes out the headphones.
And there's no way to record that?
If you come out the headphones, you can.
Gotcha.
You just go into an input.
Gotcha.
Yeah, I know. Because that's.
Yeah, you just put it on.
I know.
I know. I mean, obviously we're recording the wrong mics, but
in the air tonight, right here for free, So yeah, you just come out of one of these out.
It'd be interesting to hear what it sounds like.
Yeah, you can set one of these up, come out of here, go into an input, and use it as a recorder. Well, we probably should put an output on the back, but I got so many, it's ridiculous. But but that's what that's for. And when you're dealing with vocalists, especially like with this or with this, you got vocalists sitting there, and you got all four of them plugged into the front of this. You bring this up, and they don't have to take their earpiece off anymore because they're hearing directly what the other person is doing. The thing about a drummer, a lot of times the reason a drummer wants a little bit of reverb is because if he's playing right in the pocket, he can't hear his snare hit because it's hitting with everything. So it's masked by everything being on time. So by him hearing the reverb, he knows that it's there. And that's the same reason why some singers sing flat without they live.
Yeah.
Is because they can hear themselves in the monitors better.
Yeah.
And it's kind of weird, but people do that. I know a guy that used to sing, he was constantly flat. They just put a harmonizer out in the front and just pitched it up a hair. But he sang flat so he could hear himself.
Gotcha.
But this is a pretty cool unit. It's got 4 headphones, two on one amp, 2 on another amp, so you have 2 different feeds. And
what's the different
So yeah, A and A is one volume, B and B is another volume, and you can take the output of this and plug it into that and have 4 more. So you can have 7 headphones off there. It's like
so my horn section doesn't have that
string section, right? Because those guys will never get done mixing their headphones.
Exactly.
And then on the back you got D subs 1 through 8, and on the bottom. So if you have heavier cables, they come out of the bottom. You know. And you also have the last 4 are in here, so you can plug something in, and then the last one goes to 1/4 inch. You can use the 1/4 inch also as a talkback input from our control room module, which is the next thing we're going to talk about. This right here, this has got 4 inputs external plus Bluetooth.
Yes.
Pair your phone to it and just do it like a girl. This knob, when you first turn it on, you'll see it go and turn down. It's motorized. The reason it's motorized is everything on the front panel is disconnected from everything on the inside through a microprocessor. So when I hit this button, it clicks this relay, but it's really going to the computer, and the computer's clicking the relay and then telling it to turn the light on. So these are all clicking relays. It's all analog internally, but the reason we have a motorized pot is because you've got 3 sets of speakers. And you
so smart.
You see, so now your second set of speakers, you need to turn them up a little bit. Okay, so what I do is when you go to speaker A, you adjust this to where you like it. Then you hit B, and now it's lower. So you hit B and hold it, and when it blinks, you turn this up to the level you want. When you release it, this turns back down to that point, but the volume is higher.
You know how many times
I know
I've been on the big speakers, which are normally on B, and then you switch back to A on the NS10s, and it's like pop.
Yeah. And so that's the reason. Everything I do are things that annoyed me. Okay, so smart. And then once you get to that level that you really like, you press and hold this button, and it stores it. So if somebody wants it, but because says, "Hey Guru," and he just, fuck, I just spent the last hour getting my level set. You hit this button, and it immediately changes, but the volume pot goes back up to where it was. You know. So you've got an external talkback mic and an internal one, same talkback circuit as this. This right here is your LFE, and if you press this and hit that, it'll turn it on, and you hit this and go back, it's off. But if you press it and then hit it, it stays on. So every time I hit A, the sub comes. Then you've got this Alt button is for programming features that we're going to have for the future. So then you got a headphone output that monitors this, and you can set it up internally so it's pre or post this.
Okay.
Most people just have it, it's pre this, so this is separate from whatever this is. So you can turn this down and you can still have this on. And then an external input which comes in the back that allows you to have a cue mix from here going to this, and then this right here plugs into your control room.
Nice.
Then you've got 8 talkback outputs.
Yes.
And you have talkback and dim. And when you hit talkback, whatever you've preset with these, like if I just turn these 4 on, when I hit this button, it talks to those 4. But if I want to talk to just him, I press it and hold it, and it will talk to just him.
Gotcha.
And that you go into here.
Mm-hmm.
And then you've got your microphone gain, and then you got your talkback gain. So microphone gain allows you to set the level going into the preamp, so you can hit the compressor a little harder if you want. And then the last thing is the input mod. And this is pretty cool because this has everything that's ever pissed me off designed out of it.
Okay.
First thing, you got 3 inputs, so you can use all 3 at the same time. So if you got 6 background vocals and 2 channels, you can bring them all in here and mix them in Pro Tools and just bring them in here. Okay, so that saves channels. Then there's an overall trim. You got 2 mono sends and then 3 stereo sends. So those sends can also be used as buses. So you can put your drum kit through it and send them as so you can set up 3 stereo headphones, but you can also use one of them as a mixed bus.
If I'm mixing, then I'm not sending headphones, and that becomes 3 stereo buses.
Right. And the master section, you can take those. Each one of these 3 goes into the Grand Master, and the Grand Master has its own insert. Okay. These also can be assigned to the Grandmaster. So you can literally have 6 stereo mixes going into the Grandmaster, okay, which is very cool.
And comparison, if I'm comparing the sound of A to B.
And you can do that with this one. You can go stereo A, stereo B, stereo C, Grandmaster, and you go, I like A better than B.
Right.
You can put everything through everything and just run your whole mix and go, oh yeah, I like C better, Then coming up, you have the tilt EQ. Okay. Then you have a high and low pass sweep filter, and that's a Bruce Swedien trick. I've always mentored that guy. He's been my favorite. He's been my favorite mentor to me as far as his techniques and the things that he does and the reasons. The reason he does the filters was because he could put a piano in a mix and he would adjust it, and then he'd bring the filters in until he could hear it cut into the piano, and he'd pull them out a little bit. So in the mix, the piano sounded perfect. You solo it, and it sounded a little pinched because he's removed this stuff, but the stuff you never hear.
Right.
So that opens up that whole area, and that's why his mixes always sound so airy. Is because he used filters a lot, because he was also really good. Yeah. And he also, anything that was below like minus 20 or 30 on a fader, he's go like, really? Turn it off. Then you have an insert with an insert here, but you can blend it. So every channel has a blend.
Okay.
So you can blend between wet and dry on every single insert. And the same with the masters. They have an insert in the blend. So that's the basic function. Then you have the DAW mode, that when you press this button right here, it takes input 1, puts it into this level control, into this panner, into these buses.
Okay.
And that's what you monitor with.
Okay.
Then input 2 and 3 go all to the rest of this that you record with. So on a 16-channel console, you can record and monitor 16 at a time. Now you can hit the fader flip button, and now this fader becomes your monitor. And when you're done, if you release this, your faders are in the position that you want to play back in. The solo function is cool. This also has a fader to 0 function. So if you want to bypass the fader while you're mixing,
that's great too. If I just want to go through faders right 0.
Yep.
Just for the sonic.
You don't have to worry about it.
Yeah. Gotcha.
And if a fader fails, you can hit fader to 0 as well. Solo is interesting because in solo mode, this turns yellow. Solo in place mode, the cut lights come on, but they come on blue. And if you mute the channel of course turns red. But if the blue is on and you mute the channel, it's purple. So if you're in solo in place mode and you've got your drums muted, you can still see that they're muted. Most of the time they just all mute.
Right.
And you don't know what's muted or what isn't.
Right.
So if you're going to do it, like you want to do an analog and old-fashioned breakdown, okay, you solo the channels you want to play, and then you mute the ones that you don't want to come out first. And then when you unsolo it, those come out with these, and then you unmute those and they come in. That's one of the reasons I do that. It's kind of old school, and nobody ever does that. But then, like I said before, every single switch in this module goes to a relay. Those are all your pre-post sends. Right in here, this is your input, the 3 inputs, and the 4th one, which is an external in. So this external in button makes this level and panner for these right here into a separate mixer. So on a 16-channel console, you can not only have 16 times 3 coming in, but you can also have another set of inputs coming in here and use this as a separate mixer. Another really cool feature, if these are off, if these are all out, if you press this button, this pot now takes this external input and returns it back into the channel. So if you have a guitar, you send it through a pedal out of the direct out. You go out to the pedal, you come back in, it comes back into this point right here. You can blend it back with the channel and you don't waste a channel.
Right.
Which is very cool. So this is the shizzle. Another thing for protection, and this I learned from the Woodstock thing where the guy plugged the phantom power in and took out all the time code things. The ones that didn't go away were the ones that had diode protection on their inputs. And I don't get them back. I mean, you get a few infant failures of parts coming off or things breaking, and then after that, I just don't ever hear from people.
I guess my next question is an overall question. The older I get, the more I feel like the people who have like all of this type of knowledge, and I don't mean just how something works, I mean the actual experience of doing it, right? It has to be passed down to someone.
That's a big question because, we're all not going to live forever. And it's something that I try to do like today. Mm-hmm. Okay. Yeah. I'm 71.
I appreciate it. But I mean, like, obviously, like, full apprentice mode. Like someone needs to be your apprentice.
Yeah, and
your information cannot just leave.
It doesn't. And when I lived in Nashville, I used to teach at Blackbird. And what I would do at Blackbird is I would just open the floor and I'd say, "Ask me anything you want." And the questions that these kids would ask, and you had to make sure that they knew that no question is stupid, because some of them would ask you like a question and be like, you're like, with us, it's like, really?
Yeah. I get it.
But they don't know.
I get it. Yeah.
And the example that I've told, these guys have probably heard this story a million times, but if you give a kid a coloring book and some crayons, they do this. And what are they doing? They're coloring. Why are they coloring? Well, you said, do you want to color?
Yeah.
And they go, yeah, I want to color. So they're coloring. Now, if you say to that kid, you know what, fill in these areas and turn this into your own art, you know, then all of a sudden it's like, oh, they didn't know it. They didn't know that book was to color the pieces. They just thought you gave them a book of paper and they're coloring. Until they know, they don't know. And we assume they know.
Gotcha.
And that's what a lot of teachers do that are bad teachers, is they assume that everybody knows what they already know, but they don't understand they're teaching people.
Right.
So you can't assume that a person knows anything. When they do, that's great, but they don't a lot of times. And so some of these students were starting out at literally ground zero, and the questions they would ask me was like, you know, why is the sky blue? And it's because you can't look it up anywhere.
Is there, I struggle with this too, because people come to me and they're like, well, what books do I get? What place do I go? Or I'm like, well, yeah, if you were like trying to become an electrical engineer that's going to engineer like the lights in this building, yeah, you go to school for that. But there is no like school I can send you to that's going to teach you how to build boards.
There's no acceleration path.
Yeah.
You know, when you got interested in this, did you say to yourself, you know what? I want to be Jay-Z's engineer.
Yeah, no.
That's what I'm going to do tomorrow. I started today. Tomorrow I'm going to call him up. I'm going to say, look, I'm going to be your engineer. And he's going to go, who's this? Yeah. And this is the thing, is I hate to say to people that you got to pay your dues, you know, and all that kind of stuff, because it's really not like that, but it really is. You have to get to that point. I never started getting people to believe my things until I got to a point where people would hear it from other people in the same experience level, and they would realize that I did. One of the biggest things is, and this happens with engineers too, is a lot of times an engineer will work on a project will make it big. Now all of a sudden they go, shit, I'm on my way. And then all of a sudden they're finding themselves assisting again. And it's like, why is that? And it's like, well, it's because you just did Michael Jackson's record, but this artist doesn't want to sound like Michael Jackson, so he doesn't want you to be his engineer. So now you got this whole other thing. You got to go like, well, what do I do? And it's like, well, you got to have another hit, and it's got to be with somebody else.
Right.
And then you do a country guy, you know, then you do a pop guy, and now all of a sudden it says, yeah, this guy's versatile. He can do whatever. But you never know. It's paralyzing. Now, when I had API, I bought API in WIM, the company.
What made you think of that? I mean, I know the backstory, but what made you think of, hey, I can do this? Like, let me go gather up $200,000 from someone.
Arrogance.
I get it.
Ball. Stupidity. Yeah, I can do this. It's like, yeah, I'm a knucklehead.
Got it.
I think I was 28. And I offered him $300,000 for it. The company.
Okay, I've always thought 200.
But I never paid that much. I ended up, the company. So the story goes that API was going out of business. This is the sad thing is API and Neve and most of these big companies all kind of fell apart at the same time, because you had a like this module right here. Each one of these is a studio. Each one of these studios needs a console. So I'm building consoles like crazy, because every one of these needs one of the three big console manufacturers, you know, like it was like Quad 8, API, Neve, later on SSL. SSL came at a point where people were starting to replace their older consoles. So they got into the new thing. But what happens when I sell every one of these guys a console?
Nobody else needs it.
Yeah, it's like
or one thing may break. And
but see, they didn't think this was ever going to end, so they built big factories. And you know, I mean, API had 2 factories. They had a grade school, and Neve had 2 or 3 factories. And it was just one day, it was kind of like, can you have our phone lines checked, because the phone's not ringing? Yeah, so nobody's calling. And that's called product saturation.
Product saturation. Okay.
And that's a hard thing to do. You know, it's even artists. You know, if you put out too many records too quickly, you'll saturate the market and people don't want to listen. You know, so this is something that you have to be conscious of. Once everybody has a pair of EQs in their lunchbox or whatever, how many more of those they're going to buy? And once you've backfilled everybody, So you always have to have new things to come out with it, because we're all idiots. We'll buy the newest thing that's cool, and we'll give it a shot, and maybe it will be cool, maybe it isn't, and then it goes in the closet with a bunch of other stuff, and you sell it on Reverb and don't make any money.
Gotcha.
That's our life story.
Yeah. People eat with their eyes, and then and with the new. Like I just saw it last week with new pieces of gear. So okay, great, new thing.
Yeah, and it may be
something. Too, if you're missing out, some people are just.
But you look at the DX7. The DX7, they're when you turned that thing on, the first sound it played was that sound from Michael Jackson.
Yeah.
And that was done with a synclavier. That was the guy who, basically brought FM modulation to the forefront and made it into a real deal. And that was the sound that they came up with. And it was the sound of an era. So now, they come out with a synthesizer, and the first sound is that sound because that was an FM synthesizer, but it was a few grand.
Right.
This thing was $24,000, So I mean, that's the kind of stuff that happens. And you do get people that come out with new products that are cheaper, that are easier to get. So now, your market gets diluted. You got to really think.
Gotcha.
I mean, we've got some products here that people just, they don't have the bandwidth to do this kind of stuff. A lot of these companies.
Yeah, I think that's the part that I'm trying to get to of, and I'm saying just in the conversation of, I know a bunch of guys that can design some stuff, and they'll send, like I said, my assistant, he just sent some stuff out. He got it back from PCBWay.
Yeah.
And he's like, great. Now, the difference or the distance, should I say, from that or running a sustainable business that is repeated over and over and over again is a completely different thing.
Right.
Or having a quick run of something and saying, hey, I'm putting out 100 of these. That's great. But a sustainable business.
Right.
That next month, next year, I know that you're going to be here and I can get my thing fixed 5 years from now is a huge thing.
A huge thing, yeah.
Just the information.
Because the customer, if he's smart, will think of that.
Yes.
So you've got 1 million impulse customers.
Right.
We do this like with the Pro Patch. The first 100 Pro Patches went to guys, like us.
Yeah.
Okay. They love it. They get it. Understand it. Then it goes to the next level of people. Now, those are people that aren't quite as technically savvy, so they're going to have more questions. Once you backfilled all those people, now you go to everybody on the street that says, well, if he's got one, I want one.
Right.
They don't even know what it is. They call, they go, how do I hook this up? And then it's like, oh my God, what have I done?
Right.
You have that, but you get called to do sessions because people know that you're going to do what they want you to do, and you're going to come up with your touch to it and your sound and your thing they like, so you're there. But to start out, they're not going to risk their record on somebody. Even if you say, I know I can do a good job. It's like, I know, but I got to have that guy because I can't take the chance.
Right.
Now, that guy gets in the session, the assistant, you say, you can assist, but you just got to pay attention, keep your mouth shut, And then what happens is you're doing stuff and then you get sick. You feel that, you know what, my assistant can handle today. I'm going to let him go and let him do this. I'm just going to rest. He does a really good job. And then one of the other guys in that band has a band, and they go, you know what, I'm going to ask him to work because I really like working with him. Mm-hmm. That's where the path starts. But you got to have the evidence, And when I sold API, I didn't know if my reputation was going to stay or if it was going to leave with me.
Gotcha.
And that's the most paralyzing thing. That was probably the most paralyzing thing in my life.
Gotcha.
When I did Tonelux, I did that in it was literally 3 months after I quit. I had an entire product line at the AES show. I mean, I worked my ass off. Metalwork, input module, EQ, mic pre, rack, master module, controller module, echo return module, faders, everything. I had it ready to go.
This had to be all day, every day.
It was just like going like
now,
this.
Do you fold into your experiences at API when you leave them and you're at this crossroad? Say for metalwork, I'm just pulling that. It's like, am I pulling from these guys? Am I looking for a new guy? I went with
the same guys because they were guys that I trusted, that liked me. We had relationships, and but at the same time, the first thing I said was, I do not want to clone this stuff. I want this to be my own.
Gotcha.
So I'm going all in. It's going to be me, and it's going to succeed or it's going to fail. So I did a different kind of EQ, different knobs, different panel look, different frame size, different everything. I did everything different because I didn't want to be accused of just copying. And I had my stuff all set up. And the first guy that walked in my booth was Alan Size. And I went like, here we go, And he went over and he played with the EQ for about 20 minutes. And he turned around and he said, wow, that thing sounds really nice. And that moment is when I realized that I had a feel for what I was doing. And that boosted my confidence, you know. So, and that's when I did this.
What year was that?
That was probably 2000. Probably 2000.
Gotcha.
Yeah, and then 2005 I sold it to PMI.
Gotcha. Yeah.
You know, and then I started this. I wasn't going to do this, and some guy called me and says, "I want you to build me a console." And I was like, "Oh God, here we go." Well, I'm an idiot. I'll do it. And that started the fix thing. And then I met Jared, and we merged our two companies together and moved back here and started this huge thing. And so there were, you know, everybody.
Yeah.
And of course, I go back with this guy. Adam, I go back with him back in the Slate days.
Yeah.
And the same with Josh.
Okay.
Josh and Adam and I worked together at Slate. And I did the Slate Control, did the VMS mic and the mic pre, did the Mimic Pro, did a bunch of stuff.
Okay.
You know, so it is a circle, and you gravitate to the people you trust.
Right.
And again, that's why he's here. Is because the first guy that I thought of doing it, I said, well, wait a minute, you know, and he told me what he was doing. I thought, yeah, we'll do that.
Have you seen, it's an interesting question. Have you seen sort of the effect recently of you, I don't want to say ramping up social, but to me, there's been a more pouring out from you on social media.
It's really these guys. They're the reason. And what we decided to do is not just go like, look at my new shoes. Oh, my makeup. Look at this.
Right,
I'm pretty, you know. We wanted to have some substance. So we do these little class things. And I would talk about transformers. I'd talk about things. And some of them are really short. Some of them are a little longer. But I had this year at NAMM, I had probably at least 100 people that just walked by and said, hey, love your videos. I watch them all the time. Thank you so much. I've learned so much. And they move on.
Exactly.
I learned most of what I learned was from Saul Walker. And
what was it like being around him?
He's a very quiet, very conservative, very honest, straight guy who, I mean, his first wife died of cancer, and it was in the days when nobody had insurance, and he paid that off until he died, even being married to his second wife, who he loved dearly. But he made the agreement, I'm going to pay this.
Yeah.
And I learned a lot of that type of thing. The thing I learned from him was the things that were important and weren't important.
Okay.
You know,
like what?
Like audio, you know, sometimes, you know, having a rotary switch for a gain control may not be necessary. Just a pot is fine.
Gotcha.
You know, he taught me a lot about levels, balancing levels and stuff like that, and summing. You know, his theories behind summing. And
the concepts are there at Bell Labs of certain things, and you know, like certain things.
Well, they did purpose things. That's the thing.
Yeah, but they were either solving a problem. Some things were brought up that would never become a product. It was made to supplement a service, like, you know,
right.
My service is make my phone call clear.
Yeah,
I'm not selling you this product of what I'm actually making.
Right.
You know, I guess if I'm phrasing the question, so where would like you guys go? What was the idea of like let me study this thing? And it was sort of like the Wild Wild West of, hey, I get to do it any way that I want to do it. Whereas like now we have these set up rules of...
Well, there's all, you know, that's the thing that Saul taught me about operating level and load and different things like that. You know, he said, these things are always important. You got to have calibration. You got to have operating level consistency from one thing to the next. But you're right. In the earlier days of engineering, they had, like, they wanted to do a telephone, so they invented the telephone. Now they got to figure out a way to get it from my house to your house, so they come up with something to do that. Right. Now that transformer may end up, somebody might say, you know, I need to send a signal over a long line. I'll use a telephone transformer. I think that's, wow, I could put a product like this. Plug yourself in here, plug this in there, and now you got a ground lift, you know. Right. So there is a certain amount of growth like that, but you also have the need, you know. It's like you see, one of the things that's weird is, you know, because pretty much everything I've ever designed is by the different companies that I owned or worked for is still being made and still being sold. Mm-hmm. And there's something that I have that I learned from my parents being musicians and everybody around me being an artist and a creator, and then people like Saul Walker and Rupert Neve and people like that I was very good friends with. Mm-hmm. The way that they looked at things, they saw opportunities. They were visionaries in the way that they said, you know what? I see this half the table has got stuff in it, that half doesn't, but I don't want to just make something for that. But you know what's missing here is this. And you do it, and that's exactly what's missing. But you don't know that until you've recorded stuff, until you've done live sound, until you've done concerts, you've stacked and racked, you've unloaded bands, you've done monitor mixing, you've done front of house mixing, you've been on the stage, you've tuned guitars, you've run in the studio, you've mastered things, you've mixed things, you've cut records. When you see all those things, you go around and you go like, you know what? Every day I lose my shaver. So what I do is I'll go and I'll do a 3D model and I'll print a holder that I can put my shaver in. So I look at that and I go like, here's the list of things that have just annoyed me, and I'm not going to put those things in my products. And then I find out somebody like you kind of laugh and you go, yeah, that's just annoyed the shit out of me my whole life. And I'm so glad you don't have it in your console. And then all of a sudden that starts to spread. It's like, okay, he's not messing around. He knows how to get work done, being in live broadcast where it's live. And the thing is with live broadcast, when they say this line right here, this is when we go live. And I care about what's going on here up to this point, but this is where we go live. Everything's broken, but this is where we go live. And it's like, there is no option. You don't have a second chance. You got to get things going. And that's why, you've worked shows before where it's just complete a shit show. 2 minutes before showtime, we're live, and everybody's like dead on. The artists get together, everybody gets together. They hated each other 5 minutes early. They go out there and they kick ass. And at the end of the show, all the duct tape falls off everything, and everybody goes like, ugh.
Thank you.
And I mean, that's what I get used to. So my whole frame of work is based around not wasting your time, not annoying you, not having you have to fiddle and having the singer going like, are we ready? That's what I try to do. Even to the extent was like when I would design like all the 200 series with API, every one of those things, I designed it so if you put the knobs at noon, it was a good starting point.
So you did the 200 series?
Yeah.
Okay, good.
So the compressor, the noise gate, the filters, if you put them at straight up noon, because when somebody says, hey Joe, try this new compressor I've got, and you've got Jay-Z sitting out there, and you go, hey, this guy brought a compressor, and he goes, yeah, put it in. Okay, so he just gave you a minute.
Right.
Yeah, people think, oh, he gave you permission. No, he gave you a minute.
Right.
You plug it in. The first thing you do is you set everything at noon.
Yeah.
Okay, and if it doesn't sound right, you go, yeah, it's not it, and then you put it back into the 1176 because you know how that works. That's the moment you have to be approved of when you come up with something new. So I would set it up so if you plugged into the noise gate and you set everything at noon, it would gate at 0, maybe a little sooner than you want, but it wasn't on immediately. Right. It was gated. And then it would open, it would release at a good point, it would say, yeah, that sounds good, and maybe I'll put the threshold back a little bit, and you're rolling.
Gotcha.
Because it was there. Same with the filters. A little bit of roll off on each end. That's reasonable. I'm tweaking a little bit, but I could hear it immediately when I plugged it in. Yeah. I didn't have to find a spot.
And fiddle.
And so those are the things that I've always done because to me, time is everything.
Yeah.
And you don't want to be the guy that he's in the middle of a lyric and, something happens, you hit something on the console because you're noodling around and he loses.
I have the blessing of a very mature mind that goes, and this is him as a businessman, a boss, a friend, or whatever. He'll go, how long do you need? And I go, okay, I need 5 minutes. Cool. He'll walk out, he'll come back in 5 minutes.
Right.
He could go, how long do you need? And if I say, I need 2 months, no problem.
Right.
Leave, we're gonna have fun with it. In 2 months, this shit better be done.
Right, yeah.
If I told him 5 minutes, 10 minutes, he's like, how long is it gonna take you? Because I have a bunch of other things that I could be doing, right? Like I could go do this.
Yeah,
just
and I can do it, so it's not a big deal.
Yeah. But if you tell me 5 minutes.
But your first day, you didn't have that.
Yeah, no.
Your first, he says, okay, how long is this going to take? You say, it's going to take me a minute. He says, all right, and he stands there, and in less than a minute, you get it done. Now, the next time he says, how long is it going to take? You say, it's going to take me 5 minutes. He believes you.
Right.
But that first time, you have to earn that spot. Yes. And people don't want to earn that thing. They want to go like, I've been here a month. I should get a raise. It's like, no, you've been here a month. You're lucky you're still here.
Right.
You know? I mean, it's an earned kind of like respect that you get. And you also know what you're doing. When there's a problem and you solve it quickly, he goes, oh, that guy, not only is he on time, but he's a problem solver.
And the point is the tool. You're making the tool so that
I'm trying to make you look better to him.
Right.
You know? You get done, you go, God, I'm so glad he had that button.
Right.
You know?
Right. Yeah.
Like the fader, you move the fader up and it crackles. Okay, what do you do at that point? And it's like you've got all the channels used. It's like shit. So what do? Hit the fader to 0, bring the mic gain down a little bit. Problem gone.
Right.
You know?
Gotcha.
I mean that's it. It's earned respect, and it's earned, and so you earn that respect. You don't get respect overnight.
Yeah.
You know? I mean that's something that people, when they rely on you and you don't let them down, then they know there's a cog in this wheel that if I call you up, I know that that's handled. Now I got to find this person.
Right.
Now I got to find this person.
Right. That's what I want. I want that person to look and say, hey, I assigned this. You said yes. I know that's it.
Right. And I'm done. I don't have to deal with
Keep
that.
going back and
I just took a piece of the pie out of the picture, you know.
Right.
And that's
for an artist too, at that level, there's music. There's the visuals, there's the business side of it, there's the merch, there's the you know. So it's just like, okay, the sound of the show, we're going to be great. You know what I mean? I can't tell you with the lighting guys, or you may be taking some time with the lighting guys and go, okay, I can take a little bit more time because I know my sound is going to be.
Well,
thank you.
Man,
The information,
a cool day.
A wealth of knowledge, man. Thank you so much.
And I got somebody else to visit when I go down to LA.
Yeah, man. Yeah, come on through. Thank you so much.
Well, come up. I mean, if you're up here, just come by. We'll have lunch or something.
Absolutely,
Because we got some shit to do.
I appreciate it.